All right. Today I will talk about JavaScript and cancer. Some people doesn't see a difference between JavaScript and cancer. And I will talk about how to use, how to use JavaScript to find skin cancer specifically, okay? How I develop a solution that is actually used commercially. So that's something that is used by the dermatologists already. So here is the mouse. So what's the story behind it? In 2007, I started my PhD studies, and I was thinking about what should I write about, what should be my topic, and it came out that using machine learning for some medical case would be a good idea. And skin was one of the, let's say, easiest way to actually develop, because the skin is just taking a photo. You don't need to have special devices. You need to have a special device like this one that I will show you in a minute. But it's much easier to take a photo of skin than your liver or your heart, for example, right? And so I started. And the first question was to my colleagues at the university, okay, what is the database? What is the size of the database that we have? And my colleague came, okay, we have a huge database of 53 images. If you know, building any kind of machine learning model on 53 images, not doable, right? That's something that you just can't do. So I spent 1 year, and I did a spreadsheet with all of the dermatology companies in Krakow, because that's where I live. And I spent 1 year to go to every clinic and ask them for images. They refused. They said, we want money for that. We can't because privacy, blah, 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 this kind of stuff. After 1 year, one company gave me 5,000 images. So you can imagine my colleague he collected a data set of 53 images, and I came back after 1 year giving him, look, we have 5,000 now and 53 images for this research. So that's something that I did 15 years ago. So you can imagine I'm looking at such images. I'm investigating this kind of images for 15 years now. I'm not a medical doctor, but if you show me your mole, I will tell you what it is, because I saw so many images already. For this case, I also prepared for you a Docker image with some notebooks if you would like to reproduce some of these cases that I will show you. Okay, but that's after the presentation. In the meantime, when I wrote my PhD, I finally graduated. I obtained my PhD degree a few years after I found this data set. I was thinking about, okay, that's a good model that I have built. Why actually we shouldn't apply that and give it to one of the devices so that the medical doctors can use that? Okay, and I found Heine, this producer of devices from Germany, in Munich. They have invented dermatoscopes. So the first devices for dermatologists were invented by them, and the next device that will come to the market will have my software there. So the medical doctors will use that. What is interesting also, because I mentioned 5,000. Now if you want to do a research on skin cancer, because I started in 2007, you can easily go to ISIC archive and download, 35,000, just like that, and start your research. So now it's much easier to do this kind of research than it was in 2007. So how I started, because the question is, okay, that's cool, cancer, great. Cancer is not great, but great that such a model was developed with JavaScript here, okay? So the first POC, I use PhoneGap, I use Cordoba. Remember this kind of technologies? Yeah, doesn't work so good. Well, now React Native That's the current state of the, let's say, POC, next POC of this app. And also TensorFlow.js. Anyone heard about TensorFlow? Everyone heard about TensorFlow, right? And there is a JavaScript version for it. That's pretty cool. All right, this was actually how the first app looked like. Yeah, locally, as you can see, totally rubbish. Just with the ABC scoring metric with the asymmetry, border irregularity, and the number of colors visible on the image. So quite simple. Not really useful for the medical doctors, because that's something that they do just by looking at the image. For them, it's more useful if we just find, probably the best would be all of the patterns. Okay, let's talk about cancer just for a few minutes to explain what is it about. Here you can see a mole, right? Here on the last screen. Skin cancer, there are different kinds of skin cancers. One of it is melanoma, the bad one, okay? If you don't cut it off, you will have problems, right? Because it will spread through the blood and pop up everywhere. But there are also other skin cancers that are not so aggressive, let's say. And all of them, all of the type of cancers, skin cancers, they have specific patterns. So if you see this pattern on the skin, that's this type of cancer. If you see this pattern, you can see this. And it's not about the number of colors, because that's obvious, but also like the dots, this kind of patterns. There are more than 30 such patterns. In my PhD, I found 12, something like that, 12 of such patterns that now I use in the new devices. All right, so why JavaScript? If you think about machine learning, because in the back it's machine learning, do you think JavaScript, it's the first language that you come to my mind, your mind? Right? Is it the second language that comes to your mind when using machine learning, building something? Not exactly, right? Probably you will think about Python or maybe Java, Scala, right? If you are more into big data, like Spark and so on. These are the languages that usually comes to our minds when you think about machine learning, right? So JavaScript is not the first choice when it comes to machine learning projects. A lot like many other languages, actually. A few years back, I did a presentation about Ruby. Yeah, I know. No one's like Ruby anymore, but at that time it was cool. And I showed them that actually Ruby is not so good as well in building machine learning models. The best library for Ruby for machine learning is PyCall, to call Python library, right? That's the best machine learning library for Ruby. In JavaScript, it's a bit better because there are libraries that works, like TensorFlow.js. Okay. So why did I use that? Well, JavaScript is quite easy. Not so easy maybe like Python, but it's easy enough. And it can be used on a phone. I mean, okay, if some of you use Python on daily basis, you know that you can also use Python on a mobile device, right? There are some solutions that allow you to build mobile apps using Python. Anyone build a Python library, a Python app for mobile? Briefcase? Yeah, Kiwi is another one. Yeah, exactly. So it's possible, but no one does it now, right? It's very, very rare. It's easier to actually use React Native to build a mobile app in this case. So that's one of the reasons. And actually, another reason why JavaScript is not the one that you want to pick is because if you put it on the front end, it can be easily copied, right? That's the bad thing about JS. So another topic, have you heard about MLOps? Any one of you use MLOps in your companies? Really? Okay. So next time I'll do a talk about MLOps, about MLOps. That's a quite new topic, where it's not only about developing a model, building a model itself, but also give it to the public, right? Deploy it to production and maintain it, the model. It's a whole process. It's like DevOps, but for machine learning, okay? So building pipelines, work on the data, right? Data engineering, for example, also testing the models, because it's not good if we put a model to production that is actually perform not so good compared to the previous one, right? That's also important. And there are many, many aspects here how MLOps is important in every actually project, not only the JavaScript one. So how we did that, as you can see, that's an iPhone success. Not the newest one, okay? But I got this extension kit quite a long time ago. And this is an extension kit from Heine. Here you can turn it on. And you can put this model on the device, which is a good solution, in the meaning that this will just work just now, right? Because executing such a model doesn't require any super GPU power, whatever. It's quite simple. Running, not training. And the second approach is actually to have, for example, TensorFlow servers, when we talk about MLOps, and actually have different apps that will use that through connection, through network. We'll just send the image and get the prediction what kind of model it is right back as a response. Which of these is better? Actually, both. On one hand, you need to give the doctors possibility to work offline. But to be precise and retrain the model, you should actually allow the solution to be able to send this image to the server, to the service, and allow it to retrain. Just to make it more and more precise. Anyway, the models that I have created are better than the dermatologist, so it's good enough, but make it more precise is even better. All right, so let me show you one thing. Click. I have some notebooks for you because that's our machine learning presentation here. All right. That's all on GitHub, so you can easily find it there. I mentioned that JavaScript is better in machine learning than Ruby, and that's true. But how good is it? When we talk about the whole process of machine learning, it's not only about getting the model, but also extracting the features, working with data. Actually, most of the work of a data scientist, of a machine learning engineer is actually related to the data itself and preparing data, not creating the model. If you don't know, now we have a data-centric approach. It means the architecture, choosing the right architecture is not so painful, doesn't take so much time as preparing the data, right? It's like garbage in, garbage out. That's how we say it. If you don't prepare the data properly, then you will just not get a well-performing model. So what kind of libraries we use? And when it comes to Python, we have pandas, right? We have NumPy. When it comes to JavaScript, we have pandas as well. And DataFrame.js, Recline, Dataflow.js, and so on. So we have more. What is very interesting when it comes to JavaScript, you heard this joke that every week there is a new library in JavaScript, right? That is popping, that is new. And that's also true for machine learning. If you search for machine learning libraries in JavaScript, there are more libraries for machine learning in JS than in Python. So why people still use Python? Because it's mature enough to use it in production. Because the libraries like pandas.js, right? It works. Like as you can see here, you can create series, you can create data frames. You can use this code just on your own at home. You can work around. Still, the way how you do that, that's obviously JS specific. Doesn't convince me, but it works at least. But if you compare it to the Python version of pandas, there's a huge difference. There's a huge difference when it comes to maturity, the features that are the most of the libraries that I download and check on JS just doesn't work. Familiar with that? Anyone? JS that doesn't work? That's typical, right? So pandas, that's one thing. For data frames, easy to manipulate the data here, filtering and so on. This is something that works, and technically you can develop a machine learning project using JavaScript, right? Because that's, I mean, at least you can manipulate with the data using pandas.js. Limitations, well, a lot of limitations here. But there is one thing where actually JavaScript is better than Python when it comes to libraries: visualization. We have matplotlib, we have cburn in Python. In JS, we have hundreds of libraries for visualization, right? Just to mention a few: D3.js, React Viz, and so on. So that's one of the advantage of JS for building machine learning, not just for cancer recognition, but in general. All right, I mentioned TensorFlow.js. Everyone knows TensorFlow.js, right? But what is the most popular library across all of the languages for machine learning? It's scikit-learn. Anyone heard about that? Okay, so why scikit-learn? Because it is a library that has many shallow machine learning methods. And most of the problems that you face, like 80%, can be solved with a shallow method. Not deep. Shallow means not deep, right? Deep neural networks, that's something that is complex, big, and takes a lot of time to build. If you can solve a problem faster with less resources, that's the right thing to do. That's why scikit-learn is the right thing. And there is no actually, I mean, there is JS skitlearn, obviously, and scikit-learn for JavaScript, but it doesn't work at all. Like, it is. If you find it at NPM, it is there. But if you download it, it will just not work as you think it should work. So it's totally opposite from what is actually in Python. And there is TensorFlow, right? That's the one library that works really in JavaScript. When it comes to all of the libraries, that's the one that really works. Why? Because it's not written in JavaScript. I mean, the interface is in JavaScript, but the back is in C++, obviously. That's why it works. So, same as Python, TensorFlow is not written in Python. It is famous. I mean, TensorFlow is famous because of the Python version, because there is that interface in Python. But the back is written in C++, right? So, that's why it's easy to develop different kind of interfaces, like the JS, for example. Do you know what's that? What of method is here? Anyone? Please. That's a linear regression. One of the simplest machine learning, let's say machine learning method. Some banking companies, they say they are machine learning companies for years because they use linear regression. That's a very simple machine learning method. And here's an example how to do that, how to use that. Easy, require, and it works. Obviously some warnings, that's clear. Right, so we have different kind of levels. One of it is actually the API, the interface, and the Python is the most popular, but we have it in C++, we have it in Java, we have it in Go, we have it also in JavaScript, and this is what I use for the skin cancer case. All right, so here are some examples. I will leave it for you to try it out at home. Some last functions here is actually how we predict, right, the predict method. Here are how we combine the tensors, right, the tensors, so here, the circles here, right? The TensorFlow, how they connected. It's a graph, obviously. And this is how it works. We can train, then predict the value. And we have also as I mentioned. I mean, TensorFlow is used for building neural networks. It also has Keras. Keras is a framework, it's a library, and it has this kind of a blocks. So we can easily connect blocks together and build big networks, big neural networks to solve big problems, I don't know, like GPT, for example. And yes, there is Keras.js. If you go to npm, I don't know. I didn't check that for a few years, but I can bet that it is not maintained for the last 2 years or something. It doesn't work. It didn't work 5 years ago. Doesn't probably not work now. But what you can do, what works, you can load the model that is trained in Python. So you can train it in Python and then actually load it through this library in JavaScript to use it in JavaScript. Right? So building that works like that. All right. Yeah, some of my trainings. Anyway, let's move back to the presentation. I have some nice pictures for you to show you. Here we go. Click. All right, nice pictures. Stay calm. That's just cancer. So we have 3 moles here. Which one is cancer? Is skin cancer? Who is for the number 1? Who is for number 2? Who is for number 3? Number 3. Okay. Anyone for other ones? Number 1? 1. Okay. Okay. It's number 3. Why? Let me show you. Do you see a kind of a blue-gray color here? Do you see it? I mean, okay, the lightning isn't perfect, but there is kind of a here area of blue-gray area. This is a pattern saying this cancer or this mole is already deep inside the skin. It's already met the vessels. So this is a very advanced skin cancer. Bad for the patient, but yeah, that's how it looked like. It's weird because it's blue, kind of a blue-gray, right? Why blue-gray? This one, that's suspicious, but that's not a cancer. That's suspicious because of the some patterns, like here the stripes. Here it's not regular, right? Also, might be a cancer, but that's only suspicious. And this one is just a normal mole, no cancer here. Right? So this is how it looks like. So how do I have more pictures, don't worry. But just skin cancer this time. How do medical doctors do that? They recognize cancer by using some metrics, some scoring methods, like the asymmetry, border, color, and differential structures, ABCD. Scoring method, 7-point, where you have 7 features, Hunter score for multi-layer moles, images, 3-point score, and many other ones. So more than 30 different patterns just for melanoma. Many of such patterns that they need to find on the image and to recognize that. All right. So where is the cancer? Why is it blue? I can tell you. If you see here, what kind of light is that? It's called the visible light, right? So the normal light that we see. But you can also use different wavelengths of light to find out what's under the first layer of the skin. Infrared, UV, for example. So, where is the cancer? Tell me. You will not be medical doctors. Number 2, all of them are cancers. Here, because of accumulation of hemoglobin. That's very bad. Do you remember this blue-gray area? That's here, but when you see it in a different wave with a different wavelength of light. And here you have this kind of dots here, right? Small dots that are very hard to see even, but this is also another another pattern for skin cancer, specifically for melanoma, because these are the dots that are dark. For example, on the first layer, it might be totally dark, but if you look on that on this using this wavelength of light, you will see this kind of a dot. It means it's going deeper into the skin. Oh, and that's how it looks like when you use the binarization method to find out the patterns. And this is what I did, what I used for my PhD to find out the patterns, the regularity, for example, and so on. And here you can see easily the whole inside, right? I know, no JavaScript here used. That's all Python. Oh, here we go. If you zoom on it, you can find out. Oh, it's quite irregular. I mean, that's not a big problem here. You can see it. That actually it's still irregular, but it's quite symmetric. Not too many colors, not too many patterns. That's not a cancer, by the way. All right. Let me show you some code. More code. Here we go. I'm sorry that I have so many notebooks, but that's what I do for a living. I just write code in notebooks to show people how it should look like, how you should develop your machine learning models. All right, here we go. 3 years ago, that's the one that is public, actually available. So first of all, what we need to do is to work on the border removal, right? Oh, is it cancer or not? Obviously it is, right? Because blue. Blue, if it's not by a pencil or pen or whatever, then it means cancer, okay? Yes. I hope you learned something today. But what we need to do is to take, whatever is here surrounding, because as you can see here, that's also round, okay? So sometimes they use this kind of device. Sometimes they take a square. Then we need to just take the one that is interesting for us, right? So we need to remove that and just focus. Take the skin color, focus just on the mole itself to find out if it's a cancer or not, or analyze the patterns here. There are hairs. That's another thing that I would like to talk about later. All we have here. Sorry, I didn't load it before. Here we have this asymmetry checking, right? So how to check the asymmetry in the easiest way? If this mole is if it's symmetric or not, right? This way to find it out. Or what you can do it also this way. So 8 times, right? You can have 8 zones, right, to figure it out. And that's what we did here. We did even more. We actually used this kind of a squares to find out if it's really symmetric or not, right? And then we have the values. The higher, the more asymmetric the values are. Okay. Oh, cancer or not? Tell me, is it a cancer? Obviously, it's not a cancer. Because this is old skin here. That's old skin. It will just go, yeah. That's not something that is a cancer. Anyway, yeah, that's obviously not a cancer. Here we go. Yeah, sharpness, blue veil. Oh, the blue veil, right? That's something interesting that we have developed. We have developed here a network to find out the blue color in the image. Okay, that's something that you can go through at home. All right. So I mentioned you that it's used on production. Have you developed any machine learning model before? All right. Do you know what to do to make it production ready? Okay. So let's talk about black, white box. Here's a Python code. I will show you some JavaScript in a minute, okay? Python code of a network of 3 layers. Very simple one. And here's the training. Accuracy, 98%. Perfect. And these are the weights, just from 1 layer. Okay? Okay, so now, tell me, what is this value responsible for? Any ideas? I have no idea either. That's the thing, the problem about neural networks, that they have so many parameters, so many weights that are trained, that actually having, trying to find out what each value means is just not possible. So there are different ways to do that. And here's an example of a scikit-learn decision tree. This is how it looks like. If Gini index is below this value, then true. All of the data goes here. That's an if-else statement. Okay? If else, if else, if else, if else, if else, if else. If you write it as JavaScript code, it's easy, right? Is it understandable? It is. Because, I mean, I know you don't know what Gini index is. Doesn't matter. Because if this value is below this threshold, we will actually assign the whole thing, the objects to one of the groups, and so on. And this is how we predict. Easy to explain, easy to show, compared to this one, right? And if you want to go to production, you need to have a model that is explainable. It means you need to explain how the model itself works. So what are the meaning of all of the values? So how do the engineers, machine learning engineers, explain a neural network that is super complex? Any ideas? So they use explainable methods to explain machine learning neural networks usually. So, for example, if we have an image of a dog, how to explain that that the model recognized this dog on the image? Show the features that are most important on the image to recognize it as a dog, like ears, nose, and he will just the model will show the features, so the parts of the image that are the most important to give the specific prediction. Same for I don't know, car, 2 wheels, right, or usually 2 wheels, and so on. Yeah, I have separate notebook for that. Anyway, just going back to the presentation. Here we go. So this is how I did that. Yes, that's Little Britain. Anyone saw the series? Anyway, very cool comedy series. The next thing that I'm focused now on is the boldness. Because one is a cancer. Did you saw the Oscars last year? When Will Smith did what he did? Do you know why he did that? Because his wife is sick of boldness. Specific type of. And she was bold at that time by the Oscars. And this is a very serious illness. Can you imagine that no one so far have developed an algorithm model for recognizing the pattern specific for being bold? I mean, becoming bold, right? Especially for mans, right? Because it's not that you're just turning 6 and you became bold, right? It's a process, usually, and the process is it's evaluating, it's changing. It started with a small dot and then makes bigger and bigger, right? And then you became bold at different age. And what is interesting is that there are patterns, like in cancer, that you can see that before the hairs fall. And that's what I do on research now, to also to be used with this kind of devices. If you want to play around, feel free. If you want to make I'm not a medical doctor, just a technical one. But if you want to have a diagnosis, pre-diagnosis, just let me know. Especially I see here a few people that are on the phototype number 1. So the probability of cancer is quite high. There are 6. Blonde people, blue eyes. Please use sun cream, okay? All right. Yeah, if you want to read more, I have also talks about coronary arteries, the vessels on the heart, how to recognize that. Also on osteotomy, here the doctors cut a piece of bone here below the knee, and they calculate how big this cut should be. That's something that I've developed in one of the articles that I've wrote, scientific ones. And most of these are actually used in production. For example, the coronary artery is used at one of the hardware producer from Netherlands. I cannot tell you the name, but it's a huge one. I'm pretty sure you have some devices at home of this producer, like a kettle electric one or something like that, or a hair dryer, whatever. They produce everything. Also magnetic resonance and then this kind of devices. All right, so just as a summary, you still have some time. So why I use JavaScript, even if it's not good, just for prototyping. I made a few prototypes, and that's something that is very useful, just to use it on the phone instead of Python. Python I use for obviously training the models. It can be easily also converted to the web app when you're building in JS. Just flip it and it's on the web. Easy, right? There is a huge community of JavaScript engineers. That's true, right? It's much bigger than Python. On the other side, well, JavaScript, MLOps doesn't exist, actually. Literally. That doesn't exist when it comes to any kind of library for MLOps. Even there is in Qflow, there is a piece part that is actually developed in JS, but in general, not much, not a lot. Community on ML topics, very poor. Not so poor like in Ruby, but still poor. Not big. And the libraries. Thousands of libraries that doesn't work. Someone wrote for master thesis or bachelor thesis a library, works like a linear regression, but if you download it, try to use that in production, it just crashes. But that's typical, right? When it comes to JS. So that's a bottleneck misadvantage. If you want to hear more, you can find me on YouTube on my TEDx talk, for example, on similar topic. Or find my recent book on explainability in medicine. That's published by Springer. Some other talks that I give, like psychological aspects of large language models. If you want to learn more about how to build a extrovertic GPT or choleric GPT, that's the one to attend, or talk about how to fool a neural network, how to change one pixel on an image to change the recognition, to prediction of a neural network from a car, let's say, to a monkey. That's something that's doable, easy, right? Just changing one pixel on the image, and some other methods that I show, where actually I show how to fool a neural network. Any questions? Thank you.